Hello everyone and welcome back to the second lecture of the chapter pH meter. In the last video, we discussed some topic from this chapter, introductory part, then different electrodes used in the pH meter and some another important topics related to the chapter pH meter. To continue with the same topic, today we'll discuss the types of electrodes used in the pH meter. In the last session, we have discussed the reference electrode or reference pH electrode, that is also called as calomel electrode. So we discuss some important topics related to the calomel electrode. Continue with that topic. Today we will discuss the glass pH electrode. That is another electrode used in the pH meter. So what is the content of this glass pH electrode and how it functions, and what is the diagrammatic presentation for the glass pH electrode? We will see in detail. The typical glass electrode consists of very thin walled glass bulb, which is made up of glass type of low melting point. So basically, the glass bulb used in the glass pH electrode is made up of glass material which has a lower melting point. Then the glass bulb is sealed with the help of ordinary Pyrex glass. The upper part of the glass electrode is sealed, and typically it is sealed with the Pyrex glass. That is a kind of glass. Then inner portion of the glass bulb is basically consists of the dilute HCl that will be called as a hydrochloric acid solution. Inside of this solution, that is inside the dilute HCl, the internal reference electrode is a dip into the dilute HCl solution. The internal reference electrode is usually the silver chloride, that is AgAgCl electrode, or the calomel electrode is used. The dilute hydrochloric acid solution is actually the source of hydrogen ion concentration and Cl minus ion concentration. So we use here the dilute hydrochloric acid, which is immersed in the glass bulb. So basically, that is a good source of hydrogen ion concentration as well as chloride ion concentration. The glass tube is permanently sealed at the top of glass electrode. So if you see the glass tube, that will be permanently sealed. The top portion of the glass tube is permanently sealed. The glass electrode setup can be seen here. We can see the typical glass electrode. Here the pH responsive glass is shown here. The internal reference electrode you can see, which is deep into the solution of hydrochloric acid, that is the dilute HCl, and here the mercury connection can be seen. And this is overall the high resistance glass metal cap, and the particular bulb is get insulated with the help of rubber, and this is the lead wire inserted directly into the contact with internal reference electrode, and this is complete capping of the glass electrode. So whenever we have to determine the pH of the solution, the glass electrode simply dip into the particular solution whose pH is to be determined, and it is connected with the external referee electrode or external reference electrode, and then simultaneously the EMF of the cell, the EMF of the cell will be determined with the help of potentiometer. So particularly the pH will be calculated by the potentiometer. The overall setup will be made up for the glass electrode. The typical glass electrode assembly we can represent over here. So you can see in the first section of the glass electrode, there is a there are several compartments we can see. Then initially AgCl, AgCl in the solid, along with the zero point 0.1 mole HCl. Then there is a presence of glass membrane as an internal reference electrode. Then there is a test solution connected with the salt bridge, and this salt bridge is simultaneously connected with the external reference electrode. So this overall is a assembly, and that will be called as a typical glass electrode assembly. In the first compartment, silver chloride solution, 0.1 mole HCl, glass membrane, which act as the internal reference electrode. The overall section is internal reference electrode. Then the test solution, and there is a presence of salt bridge which is connected to this uh, test solution along with the external and internal reference electrode. And this uh, overall assembly can be recognized as a glass electrode assembly. So here you have to keep in mind that what is the internal reference electrode and what is the combination, and the salt bridge is followed by the external reference electrode here. So what are the advantages of glass electrode? Why the glass electrode should be used? So there are some advantages in the favor of glass electrode. So initially the glass electrode is used for the solutions whose pH is ranges from 1 to 10. So those solutions for which we have to determine the pH. So particularly for these solutions, the glass electrode is used for those solutions whose pH ranges from 1 to 12. For pH measurement more than 12, if the solution is there and its pH is more than 12, then the glass electron should be made up from lithium glass that can be used for the measurement of those solution whose pH is ranges in the range of 14. The glass electrode suited for the constant and automatic recording and for controlling pH of the industrial processes. So particularly, glass electrode is well suited for the constant and automatic recording whenever there is a requirement of constant and automatic recording of the pH, and as well as if you have to control the pH of that particular solution assembly, particularly in the industrial processes. So there is a use of glass electrode whenever there is a constant automatic pH recording for the process. By the use of glass electrode, immediate equilibrium is gained, which allows the very rapid pH measurements, So particularly by the use of glass electrode, there is a attending of immediate equilibrium, and particularly this will allows very rapid pH measurement for the particular solutions. The glass electrode is very simple to operate. One has to only dip that glass electrode into the solution, and ultimately the process will leads to give the pH of that particular solution. The glass electrode can be used for the both types of solution, that is the solution may be oxidizing or reducing. For both the type of solutions, the glass electrode can be used to know the pH of the particular solution that may be oxidizing or reducing solution. The glass electrode does not affect to the solutions which are to be examined. So ultimately, this is very important point. The glass electrode should not react or it should not affect to the solution which is under examination. So this is the important point, and this condition is fulfilled by the glass electrode. It is not alter any kind of the activities with the solution which is to be whose pH is to be determined. For example, buffer solution, volatile organic compound, suspended matter, etc. that can be easily measured with the help of glass electrode. So popularly, it can be used for this type of materials. The glass electrode is used for the turbid solution, colored solution, and the colloidal solution. So what are the kinds of the solutions? So there are different types of solutions which are turbid in nature. Then there are colorful solutions as well as colloidal suspended particles present in the solutions. So these all types of the solutions can be measured with the help of glass electrode. So these are the several advantages of the glass electrode. So it is well suited for maximum range of the solutions. That is the good advantages of the glass electrode. So ultimately, there are some disadvantages are also there for the glass electrode. So what are the disadvantages of the glass electrode? So basically, glass membrane has a very high resistance, and that resistance in the range of 10 to 100 milliohm. So particularly, the ordinary potentiometer cannot be used for measuring the potential of electrode. So whenever the glass membrane we are using, which has a very high resistance, so in that case, 10 to 100 milliohm resistance may be there, and hence the ordinary potentiometer cannot be used in this situation. So that is one of the advantages for the glass electrode. Because of high resistance, ordinary potentiometers cannot be worked for this much higher resistance. The second condition for those solutions consist of the proteins. There are some solutions that are consisting the proteins. Then another chance that the solutions may contain the colloids or colloidal particles, and these particular protein particles or colloidal particles may sticks to the glass bulb of glass electrode, which is very sensitive membrane. So in that case, the glass electrode not shows the correct results, so it may show the incorrect results. So because of this, so it is a small mistake. Because of the colloidal particles or protein particles that can sticks to the glass bulb of the glass electrode, that glass bulb is a very sensitive membrane, and due to adhering of this particular smaller particles, colloidal particles to the glass bulb, it is not able to show the exact pH of for those particular colloidal particle solution or protein solution. So that is one of the disadvantage for the glass electrode. Then the glass electrode cannot be used for the acid fluoride solutions. So whenever the solutions containing the acid fluorides, so in that case, the glass electrode cannot be used for acid fluoride solutions. So because again, it is very sensitive to the fluoride content. Then the glass electrode simultaneously cannot use for the strongly alkaline solutions. So those solutions which are strongly alkaline in nature. So for these solutions also, the glass electrode bulb is very sensitive. So because of that, the strongly alkaline solutions pH is cannot be determined with the help of glass electrode. Then in the next disadvantage of the glass electrode, that is cannot be used for the solutions which has higher temperature, nearly 100 degrees Celsius temperature. If the solution is consisting or the solution has 100 degrees Celsius temperature, and one has to do the prolonged analysis for that solution. So in that case, the glass electrode may be very sensitive to that temperature for the longer time, and hence those solutions which are having higher temperature, it cannot be analyzed with the help of glass electrode fitted with the pH meter. So that is also one of the disadvantage. Then the glass electrode not used for the non-aqueous media due to partial dehydration of the glass electrode, particularly whenever there is a non-aqueous media. So that is if the solution is not containing water, instead of that it is containing another solvent like alcohol or another solvents. So in that case, there may be a dehydration of the glass electrode, and also again, because of dehydration, it may not show the accurate pH reading for those solutions which are non-aqueous in nature. But whenever the pH response, actually the pH response can be restored by dipping the electrode into the aqueous media. If you have to measure the pH for non-aqueous media, then one has to dip the pH electrode into the aqueous media so that it may show the accurate pH for the non-aqueous medium also. So we'll go to the next topic, that is pH meter, and what are the two main different types of the pH meter that are included in the syllabus. So pH meter is which consisting the most sensitive electrode, which is consist of thin membrane of the glass, and which is responsible for change in hydrogen ion concentration. This is used to measure the pH of the solution. It's called as actually the pH electrode, which measures the change in hydrogen ion concentration, and the instrument itself is called as a pH meter. So that pH meter equipped with the pH glass electrode, which is responsible to take into account the changes of hydrogen ion concentration, and that particular meter is generally called as a pH meter, which is equipped with the pH glass electrode. So there are two main types of the pH meter. First one is a potentiometric or slide wire type pH meter, and another one is a direct reading type pH meter. So these are the two types of the pH meter. So popularly, the direct type pH meters are generally used in the pH metric analysis. So first is a potentiometric or slide wire type pH meters. So you can see the diagrammatic presentation where the series of uh, phenomenon happen with the particular electrodes, and they transfer the particular signal to get the accurate pH for the solutions. So in this type of pH meter, glass electrode is inserted in an ordinary potentiometric circuit. The off-balance circuits are amplified electronically such that the milliammeter, so in this case, there is a use of this milliammeter. So this milliammeter can be used to detect the balance point. So it has main function to detect the balance point, that is a null point. The electronic amplifier will be act as a null point detector. So the electronic amplifier which is used along with the milliammeter, so that will be act as a null detector. The slide wire is adjusted in such a way that the meter deflection will not be observed. So there is a slide wire. That slide wire is adjusted in such a way that the meter deflection will not be observed. So the slide wire is calibrated directly into the pH units. So whenever there is a signal, so that slide wire is calibrated and that will be converted into the pH units and millivolt. So that will be calculated potentiometrically and we will see the pH reading on the instrument. So this is a kind of the complex process to determine the pH with the help of potentiometric or slide wire type of pH meters. Then the another one is a direct reading type of pH meter. So in such a type of pH meter, whenever we are concerned with the direct reading type of pH meter, so in such a type of pH meter, anode current is amplified by the circuit to give the output current, which is linear with the grid voltage. So here the main focus is on the anode current, which is to be amplified by the circuit, and that will give the output current, which is linear with the grid voltage. So particularly the result is registered on a pointer meter, which is then calibrated in pH units. So whatever the result will obtain, that will be registered on the pointer meter, and that pointer meter will be calibrated in the pH units. So this type of pH meter is designed in such a way that the zero of the voltmeter is at pH 7. So we consider the pH 7 as a neutral, but here in this pH meter, it is designed in such a way that the zero of the voltmeter is actually the pH 7 on the scale. Now here the pH meter is standardized with the pH 7 buffer, and ultimately it is adjusted to the zero calibration to give the required reading. Then second buffer, the pH 4 or 10 is used to adjust the pH to give the correct reading here. So actually, after following this process, the second buffer is used uh, for in the range of 4 to 10 to adjust the pH to give the correct reading. This protocol gives the exact linear shift between the millivolt and pH. So by adjusting all this procedure, this protocol actually gives the linear relation, linear shift between the millivolt and pH. This type of pH meters are mainly operated to give the direct reading. Therefore, particularly applied for the industrial usage. So this is the direct measurement of the pH for the particular solution by calibrating the pH at the different buffer solutions. Now in this instrument, there are some components or there are some arrangements in direct reading type of pH meter. So there are 2 or 3 functions associated with the direct pH meter. First is a control knob, and particularly it is for the buffer solutions for the standardization process as well as for the calibration adjustment. So three functions can be performed in the type pH meter, that is a direct reading type pH meter. So one is a control knob for buffers, then standardization process and calibration adjustment can be made with the help of the control knob. So when electrode assembly, that is glass electrode or assembly caliber or secondary caliber electrode, that is called as SC, placed in the buffer solution of pH of known pH, the scale reading of the instrument can be adjusted to desired value. So control knob is actually for these processes. We can do these processes for calculating the pH of the buffer solution for the standardization processes and as well as for the calibration of the instrument. The second one is a temperature probe, which is associated with the direct reading type of pH meter. The glass electrode potential is the temperature dependent for given pH value. So we know that the glass electrode is sensitive to the temperature, and it is temperature dependent for the given pH value. Hence, control of probe is necessary to the pH meter so that the scale of the pH meter can be adjusted to a particular temperature of the test solution. So basically the temperature knob is essential for higher temperature when we record the pH at some higher temperature, so that the accurate pH can be calculated by adjusting the temperature of the electrode. When the pH meter is calibrated to 4.0, so third one is the slope control knob that is associated with the uh, direct reading type of pH meter. The slope control knob is the another key associated with that pH meter. Actually, it is calibrated with the pH 4.0, and if the electrode is immersed in another buffer solution, suppose that we are working with the solution which has a pH of 4.0, and simultaneously if the electrode is immersed in another buffer solution which has a pH of 9.0, then pH meter may not show the exact pH for that buffer solution which was previously immersed in a pH of 4.0 solution. So initially we have dipped the electrode into the solution which is consisting the pH of 4.0, and then it is immersed into the another solution which is consisting the pH 9.0. So there may be some inaccuracy in showing the pH by the particular pH electrode. So in that case, the slope control adjustment is given for the pH meter to read the pH of the another solution. So that will allows it to show its original pH value whenever we adjusted the slope control to the pH meter that is associated with the pH meter, so that particular slope control will be allowed to read the pH of the another solution that has a different pH values rather than the initial pH values. So then the electrode is again cross-checked to the buffer solution of the initial solution. Like initially we have the pH of the solution is 4.0 to check the accurate reading. Then it is assured that the pH meter is standardized to give the accurate range, to give the accurate pH range from 4 to 9. So this actually the slope control knob is for uh, measurement of the pH of the solutions which have a different pH values, and we are jumping from one pH to the another pH. So in that case, the slope control knob is given to the pH meter. So thank you very much for your patience listening. Thank you.